Assalamualaikum warahmatullahi wabarakatuh. My name is ALIF bin Abdul KHALID from BMMA Section 1 Group 1. So today I would like to present our lab report, lab 2, which is master cylinder. Before we start our presentation about our lab report, I would like to introduce our group member. First, RAMADHAN HAKIM bin HAZMAN, MUHAMAD RUZAINUDDin ISMAIL, SITI BINTI ZULKARNAIN, NURULNATSHA binti ANUAR. So we start our presentation, our lab report with introduction. The master cylinder is a control device that converts non-hydraulic pressure into the hydraulic pressure. This device controls slave cylinder located at the other end of the hydraulic system. As a piston moving along the bore of the master cylinder, this movement is transferred through the hydraulic fluid to result in a movement of the slave cylinder. The hydraulic pressure created by moving a piston toward the slave cylinder compresses the fluid evenly, but by varying the cooperative surface area of the master cylinder and slave cylinder, one can vary the amount of force and displacement applied to each cylinder relative to the amount of force and displacement applied to the master cylinder. So next we move to the procedure and our work process.
So firstly, we need to lift up the car and put the jet stand under the car. Then we put the tray under the car to avoid the fluid from the master cylinder split on the floor. For the next step, we loose the brake pipe from the master cylinder. And then to remove the master cylinder from the brake servo, we need to loose the nut that attach both of them. After all the nut has been loosed, we can remove the master cylinder from the brake servo. Then we explode the master cylinder to inspect the condition the master cylinder component. At this time, we are loosen the bolt, which is the piston stop bolt, to release the piston from the master cylinder. Then we need to hit a few times the master cylinder to make sure the piston came out from the master cylinder. This is because the O-ring for our master cylinder was missing, so we need to hit the master cylinder to make the piston from the master cylinder came out. Next, we are doing the inspection for the master cylinder component. For the first component, which is primary and secondary piston, the component are in good condition. So the next component is inner surface of master cylinder. The component is in good condition. For the next component is reservoir grommet. The component in a good condition, nothing cracked and can be used. So next we're looking for the diaphragm. The diaphragm component are in good condition. This is the reservoir tank. The reservoir tank prevent from the cavitation to occur, then thus avoid problems. It maintain high radiator efficiency and control cooling system pressure by removing cavitation. As a result, it regulate temperature from rising. For the next part, we are measuring the push rod end, which is we use to measure the push rod end before we push the pedal and after we push the pedal. The data we collect by using the vernier caliper. Then after we doing the inspection and the measurement of the push rod end, we reinstall back the master cylinder to the car. At this time, we put back the stop bolt into the secondary piston. Then when the master cylinder was reinstalled back all the component, we connect back the master cylinder to the brake servo and tighten up the nut to connect them. And lastly, we move away the tray and release the jet from the car.
Let's move to the discussion. In this discussion, we must answer 4 questions. Let's go to this question one by one. So the first question is, based on your finding, what is the effect of the push rod end length on brake? So the answer is, if the push rod depth is set too long, there will be delay from the time your foot presses the brake pedal until the brake engage, causing a soft brake pedal. If the push rod depth is set too short, there will be fast from the time your foot presses the brake pedal to master cylinder. So for the second question, name the type of brake oil used for your car. Can a different type of brake oil be used and why? So the type of brake oil we use is .3, and we cannot using a different type of brake oil. This is because boiling point of the whole fluid will be dropped. Next, name hydraulic tube that are connected to the master cylinder and where all tubes are connected. So the hydraulic tube that are connected to the master cylinder is brake line. They are the hollow high pressure metal tube that connect the master cylinder with the drum cylinder. Inside this brake line, high pressure brake fluid from the master cylinder flow, which is responsible for further brake actuation. So for the last question is, what is the function of the diaphragm? The function of the diaphragm is act as a driving brake, and the spring-loaded part act as a parking brake. In contrast to the driving brake, which is pressurized for braking, the double diaphragm cylinder also brake when no compressed air is applied.